Good afternoon, each and everyone. Good afternoon, ladies and gentlemen. This is ELIAS SINKALA taking you in Chemist 110. Chemist 120. Yeah, so you're just talking about an acid and base. Just a briefly description or briefly summarizing what is an acid, what is a base, according to different theories. According to Bloss's solar theory, an acid is a proton donor. According again, a base is a proton what acceptor. Now, what about according to ELIAS theory? ELIAS theory defined an acid is any substance that is associated in water, either partially or completely, and give out a maximum or minimum amount of hydrogen ion as only negative, as only positive charge. And also, not only that, when we talk at Mr. ELIAS on the base perspective, which a base is any substance also which dissociates in water and give either partially or completely and give a hydroxide ion as only charge what? As hydrogen ion as only charge with a negative. Yeah. Again, there's another theory which is Rastri. The Rastri theory which is there's Bloss's theory, Arrhenius theory, and also there is Lewis theory. So Lewis theory said that an acid, it is electron acceptor. It is an electron acceptor. It is electron pair acceptor. Electron pair acceptor is an acid. That's according to what? According to Mr. Lewis. Now again, he also trying to say an acid, a base, it's a proton donor. It's a proton pair donor. It's a donor pair electron, or it's electron pair donor. That's according to what? That's according to Mr. Lewis theory. Yeah. Not only that, we've got a question here which say light the dissociation reaction and the corresponding Ka equilibrium expression for each of the following acid in water. So what does this question says? It said to say what will be the Ka expression, which is an acid expression. If we talk about hydrochloric acid dissociating in water, what will be not that remember that this is a strong acid. What if this hydrochloric acid dissociates in water? What will be the Ka expression? Yeah, there's also got a base there which is HO6H5, also C6H5NHO3. That's also a base. What will be the Ka expression if they dissociate in water? So that's what I'm trying to put in place here. So let's write the dissociation reaction corresponding to Ka equilibrium expression for each of the following acid in water. Yeah, I mean these are acid, not bases. Yeah, all of them they're acid. So let's start to put in place to see what's going to happen here if you like the Ka expression. Yes. So this is what is happening. This is what is happening. Okay. So we have got hydrochloric acid. What will happen if it dissociates in water? So note that this is a strong acid. This is a strong acid. What we do, a strong acid, it has got only what? It has got only one direction. It has got only, it is not equilibrium, dynamic equilibrium, or it is not a reversal reaction. What I mean is that this is a what? This is a spontaneously. It is not non-spontaneously. It is a spontaneous what? It is a non-spontaneous reaction because it is a what? It is a strong acid. It is just dissociate what? This just dissociate completely. Completely, there's no need of reversing reaction. So what's going to happen here is this. What's going to happen here is this. So I'm going to have an acid there. Or not an acid according to Bloss's theory here. An acid is a proton donor because it's going to donate an electron here. It's a proton donor which donates hydrogen. It's going to donate hydrogen here to the what? To water here. And water here will come what? Will come in with what? Hydronium there. Get the point, right? Not only that, which means if we donate hydrogen here, it will be H3, which is this one. and occupying what? Occupying hydrogen what? Occupying a positive charge here, because it has received what? It has gained what? A positive there. Get the point, right? It has gained a positive there. So if some of the books, they might write here what? Hydrogen ion here. No problem, because we define to say it's a proton donor. Again, according to ELIAS, it says it's any substance that associates in water and produce hydrogen ion as only positive. That's why I tend to put a positive here. What next? What will happen again? We're going to have, remember this is hydrochloric acid, sorry. That's hydrochloric acid. So what's going to happen is this, if it loses, which means this hydrogen is no more here, going to remain with what? Only chlorine here, and occupy what? A negative here. So what is happening here is this is an acid, this is a base, this is a conjugate what? A conjugate acid. This is a conjugate what? A base. How am I identifying this? Because this one is getting what? It has got a positive here. Want to say sometimes I want to give you a scenario, a trick part here. If you just get this, you just look at the product here, just look at the positive here. If you just look something with a positive, just want to say that's a conjugate acid, an acid with a positive charge. If something with a negative here, just want to say it's a what? It's a base. Now the trick part here is this: if an acid is a strong acid, just want to say a conjugate acid will be a weak acid. It will be a weak conjugate acid. If a base is a strong base, just want to say a conjugate base here it will be what? It will be a weak. That's what it means there. Yeah. So far so good. Yeah. If you have got any question, please you can ask in the comment section there. Yeah. So same applies with the same thing here. HOC6H5. We want to say all of them the acid plus what? H2O. Right? To avoid all those kind of inconveniences. Even yeah. So some of the general questions, some of the general books like this is general chemistry. What they do not consider if it is a spontaneously, non-spontaneously, or if it is a reversal or dynamic equilibrium equation. What does it mean? They just indicate in reversal form. Yeah, but they just put a reversal reaction. So to avoid those kind of things, those kind of inconveniences. Yeah, and also let's try to show something here. Not at all of them they're acid, please. Just want to say all of them they're acid. So what's going to happen here is this. If this one is an acid, this one is a base. So which means this one is going to donate an electron. So what's going to happen here? Going to have H what? If donate an electron to this one is going to occupy what? The same thing, hydronium A. Please, hydronium can be either hydrogen ion, no problem. Yeah. If you can put hydrogen ion, but just put all those kind of sort to say you know what you're talking about. That's hydronium. So hydronium and hydrogen ion symbolize one and the same thing. Yeah. Again, here we're going to have what? If this one again loses hydrogen ion, what's going to happen? Which means it's going to occupy what? It's going to gain C6, H what? H5. Not instead of H4. H4, not of what? Not 5 here, because it has given out one hydrogen ion, and hence it has occupied what? It has reduced to what? To 4, from 5 to 4. Hence, what's going to happen? It's going to occupy what? A negative charge here. A negative charge there. So this is the what? This is an acid, a conjugate acid. This is a conjugate what? Base. That is what is happening here. Same applies the same thing here. C6H5 NH3. This is also a what? An acid there. It might be a conjugate acid here. Plus H what? H2. Yeah, all of them they're reacting with water. Remember what is the question saying? What the question is saying. Yeah. Again, what's going to happen is going to donate an electron here. Going to have what? H3O with the positive there plus C6H5NH3. Not 3 but 2. It will what? To occupy 2 with a negative what? With a negative charge there. So this is what is to determine to determine or to write expression or Ka expression when acid dissociates in water. Note that this is a conjugate acid. This is a conjugate base. So this is what is happening. Again, to identify a conjugate base and a conjugate acid, please, you should just see If an acid, for instance, this one, if an acid loses an electron, just not to say this side to be a conjugate base. When an acid loses an electron, in the product here to be a conjugate base. What will remain here to be a conjugate base? Hydrogen has been lost. So what's going to happen here to going to be a conjugate base? Then this, where an acid has lost its electron, it will be a conjugate acid because it has gained one electron and it has occupied a positive charge. So hence it will be a conjugate acid. That's a kid that's supposed to know there. Well, in other hands, sometimes we may do not have something occupy or it's showing to say this is an ion, hence to be just pure like that. So what's going to happen, if you just see something occupying a positive there, that's not a conjugate acid in the products. If you just see something occupying a negative, that's not what a conjugate base in the products. That's how it is. If you don't know if you are not very much clear when it comes to the acid which is donating, and after donating an electron occupy a negative, or after donating an electron become a conjugate acid, after receiving an electron become a conjugate base, you can just identify in such way. Thank you very much for your attention. I really appreciate it. Stay blessed for more update on chemistry. Yes.